For centuries, humanity has stared into the night sky, wondering what lies beyond the faint river of light arcing over us. We call it the Milky Way, a galaxy so vast, so ancient, that our entire history is only a blink of an eye in its timeline. But there is a bigger mystery, one many people still ask today. How did we capture photographs of our galaxy when we live inside it? Tonight, we embark on a journey across light years, technology, and time. This is the story of how humanity managed to visualize the impossible, our home in the cosmos. What is the Milky Way? To understand how we photographed it, we must first understand what it truly is. The Milky Way is a barred spiral galaxy, about 100,000 light-years across, containing over 100 billion stars. Our Sun is just one star among them, residing in a minor arm called the Orion Spur. We're not at the center. We're not near the edge. We're somewhere deep inside, surrounded by cosmic fog, dust lanes, and stars. This makes photographing the galaxy similar to trying to take a picture of your own house while standing in the kitchen. So how do we do it? The limitations of our perspective. From inside the galaxy, our view is blocked. Huge clouds of dust obscure the center. Spiral arms overlap. Light from billions of stars blends together in a hazy glow. Even the most powerful telescopes cannot simply snap a picture of the entire galaxy from the outside. So scientists needed to be creative. They had to reconstruct the Milky Way the way archaeologists rebuild ancient cities, piece by piece. Their tools? Starlight, dust maps, radio waves, parallax measurements, and thousands of datasets from orbiting observatories. The Milky Way picture you've seen is not a single photograph, but a masterpiece built by decoding clues from all directions. Using radio waves to see the invisible. In the mid-20th century, astronomers made an extraordinary discovery. A single, simple particle, neutral hydrogen, emits radio waves at a wavelength of 21 centimeters. Unlike visible light, radio waves pass through the dust clouds blocking our view. This revelation changed everything. With radio telescopes like the Arecibo Observatory, Green Bank Telescope, and arrays around the world, astronomers mapped hydrogen clouds throughout the galaxy. By measuring Doppler shifts, tiny changes in wavelength caused by motion, they could determine how fast these clouds were moving and how far they were. Piece by piece, arm by arm, scientists stitched together the first real map of the Milky Way's spiral structure. It wasn't photography, it was galactic cartography, and it worked. Infrared seeing through dust. Next came infrared telescopes. Dust blocks visible light but glows in infrared, revealing hidden structures. Infrared missions like the Spitzer Space Telescope, WISE, and ground-based observatories in high deserts scan the sky in wavelengths invisible to human eyes. These scans uncovered hidden star nurseries, the true shape of the central galactic bar, dense clusters near the core, stars behind thick dust walls. This was another layer of the puzzle, another step towards seeing our galaxy from within. Gaia and the stellar revolution. Then came one of the greatest space missions ever launched, ESA's GAA. Gaia's goal was simple but monumental. Map the precise location and motion of over 1.7 billion stars. By measuring tiny shifts in star positions, called parallax, GAA created the most detailed 3D map of the Milky Way in human history. This data allowed scientists to reconstruct the Sun's position in the galaxy, the thickness of the galactic disk, the shape of spiral arms, streams of ancient stars from long-dead galaxies, and even the galaxy's rotation curve. This wasn't just mapping. It was turning the Milky Way from a vague concept into a measurable, modelable structure. The art of reconstruction. At this point, astronomers had radio maps, infrared maps, star distributions, motion data, cluster locations, dust models, spiral arm simulations. But they still had no literal photograph. So how do we get the iconic images we see in textbooks? The truth is profound. Our picture of the Milky Way is an artistic reconstruction based on scientific data. It's created by combining measurements, colors, and models to produce a visual representation of what the galaxy would look like if we could step outside it. No human or spacecraft has ever left the galaxy to take that picture. Not even close. But the reconstruction is incredibly accurate. because it's anchored in real observations, comparing with other galaxies. One more technique helped refine our understanding, comparing the Milky Way to nearby galaxies. Galaxies similar to ours, like Andromeda and Triangulum, give us a visual reference. By studying their structures, astronomers can infer the likely appearance of our own. These comparisons reveal the bar shape in the center, the number of spiral arms, the size of the halo, the thickness of the disk. Studying neighbors helped us understand ourselves. The future of galactic imaging. Could we ever truly photograph our galaxy from the outside? Not anytime soon. To escape the Milky Way and look back, a spacecraft would need to travel tens of thousands of light years. Even at the speed of light, such a journey would take longer than human civilization has existed. But future missions may enhance our model. James Webb Space Telescope will refine dust and star maps. NASA's Roman Telescope will study galactic structure more precisely. Next-gen radio interferometers will map hydrogen with unprecedented detail. Simulations using AI may one day produce near photorealistic models. The goal isn't just the picture, it's understanding our home on the grandest scale. The answer: so how did we photograph the Milky Way when we're inside it? The truth is this: we never actually photographed it. We reconstructed it through radio waves, infrared light, stellar mapping, motion tracking, comparisons to other galaxies, computer modeling. Not a snapshot, but a cosmic mosaic. The Milky Way is more than a galaxy. It is the cradle of every human story, every dream, every invention. And even though we've never stepped outside it, humanity has found a way to look back and imagine it in its entirety. That ability, the power to see the impossible, is what defines us. Thank you for joining us on this journey across the galaxy from the inside out. If you enjoyed this video, please like, subscribe, and join us again for more adventures into the mysteries of the universe.